Today we are going to look at problem 22 of LeetCode generate parenthesis. So what this problem tells, given n pairs of parentheses, write a function to generate all the combinations of well-formed parentheses. Well-formed parenthesis means it should be a valid parenthesis. So they have given the example. So if you look at first example, input is given as n is equal to 3. So these many valid parentheses, well-formed parentheses we can generate. So everywhere you can see the open bracket is number of open brackets are equal to number of close brackets. So let's see the second example. So n is equal to 1 is given, where one open bracket and then close bracket. And open bracket is always before the close bracket because it should be a valid combination. So to see how we can approach this particular problem, we will try to dry run it with the different type of examples. So first of all, let's think like this problem is it a recursion problem? Yes. How we can identify it as a recursion problem? Because it's asking generate all the combinations. When when problem states about generating all possible solutions, then mostly it is a recursion problem. So let's go to OneNote LeetCode 22 generate parenthesis. So let's take a first example, which is n. N is equal to 1 means we have given one pair of parentheses. So one pair means one open bracket is given and one close bracket is given. So when we want to form any valid or the well-formed parentheses, then for one n is equal to 1, as one close bracket and one open bracket is there. So either at the first place I can put the open bracket or the close bracket. So there can be two possibilities basically. One can be open and another can be close. So with placing the open bracket at the first place and with placing the close bracket at the first place. So if I place the open bracket at the first place, then there is only one place, and we know we have only one open bracket and one close bracket. So in this case, we cannot open further, and we have added one close bracket here. And another possibility can be at first place, I can start with the close bracket. So if I start with close bracket, whether it is giving the well-formed parenthesis, no. So this case is not possible, where this case is possible. So by seeing this simple example, what inference we can make? Like at any time, number of open brackets is equal to number of close brackets. This we can easily see, right? Because here also first I have added the open bracket and then I cannot add one more open bracket because I have given a one pair of bracket, which is one open bracket and close bracket. So by this we can make this first inference. And second thing is, at this place I am not able to add the close bracket. So number of open bracket at any point should be greater than number of close bracket. To see this, we can go further with n is equal to 2. So means we have given the two pairs of brackets, open and close brackets, right? So let's see. If n is equal to 2, then we'll have 4 places. 1, 2, 3, 4. So as per the first condition, we can say that like number of open brackets should be close. So let's see with open and close. So 1, 2, 3, 4. I added the open bracket at first place. Then my remaining sub problem will be this, right? And here number of open bracket is equal to 0. Number of close bracket is equal to 0 at a starting. And can I add 1, 2, 3, 4? Can I add the close bracket here? No. So it will not give well-formed parenthesis or the valid parenthesis. So this is not possible. So further, if we go with this case, now here 1 2 3 4. Here also 1 2 3 4. We will consider this as a closed case and we will consider this as an open case. So at here, open bracket is equal to 1, close bracket is equal to 0. So if I consider the open bracket, and so can I add the close bracket here? Sorry, open bracket here, right? Because it is the case for the open bracket, and here I can add a close bracket. Yes, because the number of open bracket should be greater than number of close, and number of open is equal to number of close. So here open is equal to 2 and close is equal to 0, and here open is equal to 1, close is equal to 1. So if we move further, again for the open case and close case, so here we have 1 2 3 4 places, here also 1 2 3 4 places. So at this position we have checked open is equal to 2 and close is equal to 0. So let's continue with that. So here number of open is equal to 2. Can I add one more open? No, because always number of open bracket equal to close bracket. So we have only two open brackets. So we have two open brackets and the two close brackets. So already I have exhausted the two open brackets. So I cannot add one more. So this is not a possible case. But in this case, if we check, we have added the two open brackets and one close bracket. So this is the possible case. And here open is equal to 2 and close is equal to 1. So we'll go further here for the fourth place, 1 2 3 4, 1 2 3 4. So we have already added open bracket, close bracket, and open condition is not possible because number of open bracket is equal to number of close bracket, and at any position number of open bracket should be greater than that close bracket. So here if we already added one open bracket, two open brackets, one close bracket, and so this case is not possible. And at this we can add one more close bracket. So we are getting one valid or the well-formed parenthesis with the number of pairs given. At this place, if we consider, there will be again two cases, 1 2 3 4, 1 2 3 4. So here I have already added one open bracket, then close bracket, and now I am again considering this branch as open and this branch as a close. So can I add the open here? Yes, because number of open is greater than number of close. So open is equal to 2 and close is equal to 1. Here I have added one open, one close. Can I add close? This is not possible because number of close are getting greater than number of open. Again check this condition, open and close. So here I have open, close, open, and one more open can I add? It is not possible. Why? Because number of open equal to number of close. I have already exhausted 2, and if I add one more, then it's not possible. We don't have that pair. Here I have added open, close, and then further open and one more close. So this is the one more valid parenthesis we are getting. So these are the two things we are getting through the with the example of two pairs given in the example. Now if we consider for n is equal to 3, I am adding because new page, n is equal to 3. So in this, number of open will be 3 and close will be 3, right? So we will have 1 2 3 4 5 6 places. If I start by considering open and close, definitely it is not possible to add at a first place. So let's see with open only 1 2 3 4 5 6. I have added open. Here open is equal to 0, close is equal to 0, open bracket. Then furthermore, so here open is equal to 1 and close is equal to 0. Furthermore, 1 2 3 4 5 6. So here already, so this branch is for open, this branch is for close. We have open. Can I add one more open? Yes, that is possible. Open is equal to 2, close is equal to 0. Here 1 2 3 4 5 6. Already added open. Can I add close? Yes, that is possible. Open is equal to 1, close is equal to 1. Let's go further, open and close. So here I have already exhausted the 2 open, and we have, as we know, we have 3 opens and 3 close, right? So let's see further. 1, 2, 3, 4, 5, 6. So open, open. Can I add one more open? Yes, that is possible. Open is equal to 3, close is equal to 0. 1, 2, 3, 4, 5, and 6. So I can add 1, 2. Can I add close here? Yes, that is possible. Open is equal to 2, close is equal to 1. And if we see further, with this case, open and close. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I have added 3 open already. Can I add one more? No, we have only 3. And with the case of close, I have added already 3 open and 1 close. So this is possible. Let's go for this branch first and we'll check further. Okay. So this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here 1, 2, 3. And can I add one more open? No, not possible. With this case, close and open case, 1, 2, 3. I can add one more. Again, open is not possible. Close is possible. 1, 2, 3, 4, 5, 6. 1, 2, 3. Already close to and here. So this is one valid parenthesis string we are getting here. Similarly, let's see for this. I already added 2 open, 1 close, 1 more open, and 2 places remaining. And for the close case, 2 open, 1 close. Can I add one more close? This is possible because number of open should be greater than number of close. So here, and then 2 places are remaining. For this, if I consider open case, and for this I consider close case, in this already I have exhausted number of open brackets we will have. So this is not possible. And here close bracket. So open, open, close, open, and I have 2 places, right? So this is the case of close. So one more place is remaining. And in this case, first let's finish this case. This is not possible now. This is possible. So this case means close 1. So this is one more valid parenthesis we are getting. And in this case, can I add open? Can I add close? So here I have already have 1 open, 2 open. Can I add 1 open? Yes, that is possible. And now again, see for this case, open is not possible. We have only 1 place, and then we can add number of opens should be equal to number of close, right? So we can add only with the close case, we can add 1. So this is one more case. And for this case, if we add a close bracket, can we add a close bracket here? No. Why? Because at any point, number of open brackets should be greater than number of close brackets. So I have added already 1, 2 close bracket. And if I add close bracket here, which is not possible because 1, 2 open brackets and there are 2 close brackets. So if I add here 1 close bracket, then number of close bracket will be greater than number of open. So like this, if we do recursion for all, and once we get the valid solution, valid parenthesis, we can return, 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 and we can add into the all the like result of all the possible list of valid parenthesis string. So this is how we can do the dry run for the valid parenthesis. Let's see the solution. So now once we understand the dry run for this valid parenthesis case, then the solution becomes very easy. So first of all, as we understood, this is like we need to calculate all the possible combinations. Then this is the recursion problem. So what is the standard step we use in the recursion? Express the problem we says like in terms of the index, but here it is like open and close bracket, open and close bracket, in terms of function with open and close bracket, do all the possible variations and find valid combination, and third, base condition, right? So now the solution is very easy. We will be expressing the given problem in terms of open and close bracket, and what we want to return, that is a list of strings. So list of valid parenthesis string. Here this is one string, here another string, third string, fourth string. So we are returning the list of string. List of string result is equal to new array list, and we want to write a we want to express the problem in terms of number of open brackets. So initially when we are considering, as we were doing the dry run, we have seen like we are considering the string as a blank string, and number of open bracket and number of close bracket at a starting are 0, and how many pairs are given, that we are passing, and then we are passing blank string, and then we are passing the, that is nothing but our current string. So that will be a, at every place we are updating the current string with the open bracket or the close bracket, depend on whether we can, at that particular position, whether we can add the open or the close bracket or not. And then we are passing the result because we want to return whole list of possible parentheses, valid parentheses, and then at the end we'll be returning the result, right? So let's see, we are writing the function which is like return type is void, and we are passing open bracket, we are passing number of close bracket, we are passing int n, number of pairs of the parenthesis given, and then string current, and then result will be returning. So list of string, that is result. And let's see now what we are saying, like do all the possible variations and find the validation. So what we were doing, either we were adding the open brackets or we were adding the close brackets. That only we can do, that only we can do at any point in any position. So we will update the current string with that particular bracket at any point. So if we can, if we want to add the open bracket, then what we are going to do, we'll add the open bracket at that position, and we'll increase the open bracket by 1, and we'll remain the close as it is, and the current string will be updated with the open bracket, means appended with the open bracket, and then we'll be returning the result. And in similarly we can add the close plus 1, and current will be getting updated with the close bracket, and then will be at the end, once we got the, once we covered the length of like number of open brackets and close bracket, we'll be adding it to the result. Now the thing is, when can we add the open bracket, right? So if open is less than n, then we can add the open bracket, that is correct. But when can we add the close bracket? Always open should be greater than close. At that time only we are able to add, as we have seen into the dry run. And at the end we want to update the result. So if open is equal to close, and open plus close bracket, suppose just take example of 3 pairs, then 3 plus 3 is equal to 6, means 3 is only the n number of pairs are given, so actual count will be 6 brackets. So if it is equal to 6, sorry, equal to n, then what we'll be doing, we'll be adding, we came up to the end of the length, so we'll be adding the result dot add current, and then we'll be returning. I think it should be okay. What did we miss here in number of pairs given? Okay, so this is the basic solutions with which we can find out generate all the combinations for the well-formed parenthesis. Let's submit. Yes. Okay. I think this is the solution. We'll see like what is the time complexity and the space complexity for this solution in the next video, and then we'll see further how can we do with DP. Thank you.